Good evening, everybody. This is Jack Long. I am the Mad Scientist, and we're going to be discussing hoses for dust collection systems, and this is video 4 out of 5. So let's get into it. So let's say that for some reason you have somebody that likes to take some of those very simple economy dust collectors that you can buy, and I do not mean that as an insult to the purchaser or the designer. It's, you know, those 2-bag units that they have where they have the 3 ports that come out, and when you're looking at the side of it, it's one of those. You got the barrel that's here, the barrel that's here, dust bag, filter on top. You know, we've all seen them. I've had a couple of them in the past myself. They're not bad units. Kind of look like this, and then they got the port here. And out of this port, we have a 7-inch with 3 4-inch pipings that come off of it. And so what people will do a lot of times is they'll just come into this and they'll connect onto it with hoses. And then they'll run the hoses to whatever machine it is, and sometimes the hoses go up and they lay down and all that stuff. For starters, hoses should be the last connection at the machine. It should not be part of your actual dust, your trunk lines or anything like that. It should be used sparingly. And the reason for that is just like everything else that I've been beating everybody up about efficiencies inside your pipe. When you got your dust collection hose, you have that steel cable. It goes around and around and around and around and around. It goes through it, and they put that rubber. It goes across it of whatever the product it is. Actually makes it into a hose. This size in here is smaller than what they call for. So if they're telling you that it's a 4-inch, for instance, it's smaller, just negligible, but it's smaller. And because we have all these little ribs and everything that's in here, this creates turbulence on the inside. Creates turbulence over here, and I have beat this point up, I think, enough that turbulence is not our friend. Okay, so when we're using dust collection hoses, we want to use them sparingly. You want to use a better quality if you can afford it, because there's different efficiencies based on how the hose is manufactured. So what I was getting at with the hoses is when your hose comes out and your hose goes up like this and your hose comes down because somebody has taken a piece of rope and tied it off to the purlin up above, and you got this nice sharp bend in it. This bend gets into your efficiency again, because now the air's got to go up and the air got to come across, and a lot of times this is not a nice gradual bend. It tends to have a little kink in it, and because you're doing that, now you're making a 90-degree turn with your air, which I've already talked about before is a no-no. And what happens is when you start going in and looking at the quantity of air that actually passes through the hose and goes in, your CFM falls, and it falls significantly. Okay, and I'm not going to give you an exact number, but I can tell you that it's going to be in the middle double digits, 30% maybe, 40%, something like that. I mean, it drops off significantly because your air is trying to go up and your particulates are going up and they're being slammed against the outside, which is reduces your efficiency again as it's going through. So they're stalling out as they're going across. And all in all, it's just a bad situation. Okay. The other thing that you want to keep in mind when you're using your dust hose, when you're making your final connections, if you're hooking it up to a CNC, for instance, as the CNC moves around, let's say that I'm looking at my CNC from down from the ceiling. As that head moves back and forth in its X and its Y, that dust pipe is static. It does not move, but your hose has got to be dynamic. So as it's moving back and forth, you're taking that hose and you're actually twisting that hose as it moves around. It doesn't just fall and go over here and come back. When it returns back to wherever it was you connected it to, then it's going to uncoil, but while it's twisting up, it will coil up on you. And like everything else, if you ever watch them, your hoses will droop, and when your hoses droop, you'll get inefficiencies and you'll get dust that will settle out in your hose. And when it settles out in your hose, you'll have parts of your dust collection that works really well, and you have some that doesn't work quite as well. So the workaround for that, the way that we would handle this, if I was to come in and design your system, is you get this neat. I don't know who come up with it, but I do hope that they're retired sitting on a beach somewhere. You get this thing that looks like a basketball, and it's basically a half of a steel sphere, was a hemisphere, and then there's another mated half to it, and one half goes this way, the other half goes this way, and it allows this joint to pivot. So you got your hose that comes out here, you got your rigid pipe that goes up here, this fitting right here articulates, and it will go this way, it goes this way. It's in all three dimensions, so it takes all the stress off of this pipe. Okay, the rotational stress off of the hosing and off the pipe. All right, something else that you want to consider if you're going to be doing this against something that's in motion like a CNC is that you want this pickup point as high up as you can get. Sorry, move my pad there. You want this pickup point to be as high as you can possibly get over top of your machine so that this hose stays straight. If you have 8-foot ceilings and you have a machine that's 8 foot tall, your hose is going to droop, which is not what you want. What you want to try to do is get this up as high as you can, and I have gone in and put systems in where we had purlins, and we actually went up with an arch and come down from the top, and this connection point was up above the purlins, and it looks strange, but it worked very, very well because this was engineered with the correct radiuses, and the material went up, made its bend, and came back down. Okay, and then we had nice straight pipes. All right, depending on the manufacturer of the machine, a lot of times they have this thought process already built into the design of the machine, and they've become a lot easier to make your connections to the dust collector just because the machine manufacturers look at it different. As always, guys, be safe out there. We don't do anything that's worth going to the hospital for, so make sure that if you're up in the air that you got your fall protection and that you're taking care of yourself, because you know we all got somebody we want to go home to. And as always, let's go make a million. Have a great night.